we are going to do this potential difference example, potential difference being voltage. A uniform electric field of 10 kV per meter points vertically upwards from the ground. Remember that kV means kilovolts, or it's 10,000 volts per meter. If the ground is designated as zero potential, then A, what distance above the ground has a potential of minus 100 volts? And B, how far above the ground is a point that has a potential of minus 7 kilovolts, or minus 7,000 volts? Okay, so I'm going to draw this here. Okay, here's a simple diagram. I've labeled the ground. The electric field is in red. You can see it's pointing upwards, and the magnitude of it is 10,000 volts per meter. Just to remind you, the unit of volts per meter is the same as a Newton per Coulomb. So this is equivalent to 10,000 newtons per Coulomb. So the problem says we're designating ground as V is equal to 0 volts. Remember, we can do that. You can choose wherever your V equals 0 is going to be. Very much the same as when we did potential energy problems and you choose your Y height. And it's asking where would it be minus 100? I set V as negative 100 volts right there. The reason for the negative sign, and I know this gets confusing with voltage and potential difference, is an electric field always points from a high potential to a lower potential. So if you set the ground to be 0 and the electric field's pointing away from it, then the voltage technically is decreasing from that point. And so that's why we're giving it a negative 100, because it has to go from a higher to a lower value. And so if 0 is the high value, then anything lower than that is going to be a negative value. And that's why it's negative 100. And our goal here is to find that distance d above the ground where that negative 100 volt is. So we know the formula. You can see that delta V, the magnitude of it, it's going to be the magnitude of the electric field times the magnitude of the distance. I'm using magnitudes here because really to use vector properties to do this, you would have to do something called the dot product, and that gets a little above the math for an introductory physics level. So what we're looking for here is basically a change of 100 volts. The magnitude of the electric field is 10,000 volts per meter, and distance d. And so you just now need to find d, and just doing the math on that, we're going to do 100 volts divided by 10,000 volts per meter. This is going to give you 0.01 meter, or this is also 1 centimeter. And that's the answer for part A. Now in part B, we're just repeating the problem. We're using the same formula. This time, delta V will be 7,000 volts. The electric field magnitude is still 10,000 volts per meter. And in this case, you'll see that just repeating what we did in part A, D is just going to be 0.7 meters, or 70 centimeters. So it just is showing that as you move further away from the ground, if the ground is designated at 0 volts, you're going to get less and less value, so they're going to become negative. And these are the heights at which you get those voltage differences. All right. Thank you for watching, and if you have any questions about this problem, please feel free to contact me. All right, have a great day.